Welcome to EdVantage. I am Dr. April Strom, and what we're going to talk about today is change by a constant amount. So I've got a task for you to consider. So consider the Tesla Model 3. There's a phantom drain problem that we're going to tackle. The phantom drain occurs when the Tesla Model 3 is parked and unplugged. Zero, a Model 3, has a starting range of 250 miles. After being parked for 16 days, the range, though, has decreased to 178 miles. So what we're going to do is take a look at these values and figure out what is going on between the beginning part from 0 days to 16 days out for this particular task. We're very curious to know how, in fact, is this constant amount changing as we progress in days. Okay, so according to the problem, we have at 0 days, we have that the Model 3 has 250 mile range. Great. We also know that after 16 days, though, that it's been sitting and unplugged, we have only 178 miles left. So we're very curious, what is actually going on, and in what way are those miles draining out of our Tesla Model 3? So we're going to explore that. So let's graph what we know already. If we go to the graph, we have our input quantities here, the number of days. Output quantities being the number of miles. So we know that, again, at 0 days, we have 250 miles. That's our maximum range fully charged. But after 16 days, we only have 178. So if we graph that roughly about 16 here, we have 178 miles that we can actually drive. And I'm going to go ahead and label this 16 days elapsed, 178 miles. And again, at 0 days that have elapsed, 250 miles in the range. But the question is, in what way would we actually connect those 2 points? There are many options for us to consider. So let's explore a little bit more. Let's assume that the miles that are draining out is constant for every day that elapses. And if that's the case, let's check out what happens after 8 days. So let's say 8 days. 8 days is halfway between the 0 and the 16 that we were interested in. So at 8 days, so right about here on our input quantity, if we assume that the miles are draining out of this fully charged Tesla Model 3 at the same amount every day, then if we go half the number of days, we should have half the miles drained out, okay? So before I actually graph that, I want to talk about here. I've got, when I started for my initial drain, I had some amount of decrease here for my particular miles that were in the Model 3. I started at 250, but I ended at 178. And then I have an amount of change in number of days going from 0 to the 16 days. But if I go halfway in that amount, 8 days, then I don't quite have, as I mentioned, the same amount of decrease. I have half the amount of decrease here in the miles when I have half the amount of progression in the number of days. So after 8 days, if I'm looking closely, I have about half the distance here in the horizontal distance for number of days corresponds to half the change in miles in the vertical distance here. So halfway in this amount of quantity is about halfway in this number of miles quantity. So I have a new point that I can use to actually explore this. And when I think about this again, I have a horizontal change of 8 days, and I have a new vertical change of some amount of quantity. Okay, so let's consider this. I'm curious. We know that this is 8 days that have elapsed, but we want to know what is the number of miles left in this Tesla Model 3 after those 8 days. Well, if we know that after 16 days, I have 178 miles, I started at 250, all I would need to do there is find the change from 250 to 178. Okay? If you do that subtraction, you end up with 72 mile difference from here to here in that 16 days. From 250 to 178, we had to subtract off 72 miles. So if we have 16 days produces a decrease in miles of 72, then 8 days would produce, which is half the amount of time, would produce half the amount of decrease in the miles. So instead of decreasing by a full 72 miles, I'm only decreasing from 250 to this value by half of that 72. And so that half of 72 decrease would be 36 miles. Oops. So I need to take my 250 to figure that out, subtract 36 miles to do that particular subtraction, and I get 214 miles remaining. Now you might be thinking, well, gosh, what if we don't want to wait 8 days to figure out how many miles are actually left in my Model 3? What if I only want to know how many miles are left after just 1 day? So after just 1 day that elapses. So if we think about that, okay, we say to ourselves, well, 1 day elapses. I know that if I have one of those, go back to my original to compare, instead of 16 days, I only want one of those 16 days. I essentially want 1/16 of that change that corresponds to the drain on the miles, okay? 1/16 of that change. So one day in produces about 1/16 change in my miles. So right about here, okay? So again, we're thinking about this quantity, the horizontal quantity here being 1 day that elapses, corresponds to some miles that have decreased over here in this output quantity. We're curious what that is. Well, if we start with the 250, we could figure that out. So we know that this particular point is only going to be corresponding to 1 day, but we're curious what that output quantity is. Well, we know that the change overall for the 16 days was 72 decrease. So 1/16 of that 72, okay, 1/16 of that 72 is actually going to be 4.5. So if we take our 250 and we subtract off the 4.5 that I will decrease for every day that elapses, I get a new quantity here for my miles, which is 245.5. Okay, so that tells us something about for every day that elapses, my car is draining miles at 4.5 miles per day. So if I can check my work here, what I could imagine is, all right, I know that in 16 days, I better land on 178 miles. If I start at 250 and I subtract 4.5, and then another 4.5, and then another 4.5, and I do that 16 times for 16 days that elapses, I better get to 178 miles. So the idea here is a change by a constant amount. For every day that elapses, I drain the same amount of miles from my car. Every day, every 1 day that elapses, I drain 4.5 miles. Another day elapses, another 4.5 miles, and so forth. And when that behavior happens, the pattern results essentially into a linear graph. Okay? All right, cool. Now you might be thinking, well, I wonder how long I would have to have my Tesla Model 3 sitting in the garage unplugged and have 0 miles left to drive on it. Or essentially, when would the battery be completely drained? Okay, so that would be the question that we might be interested in. So if we continued this for every day that elapses, I reduce in my miles by 4.5, when would I reduce essentially down to 0? 0 miles, completely drained battery. Okay, well, we could see visually if I just continue my linear progression here, on down to when I hit the input axis and the x-axis, I can kind of rough it and see, oh, it looks like about 50 or maybe a little over. We're not quite sure exactly where. The graph is very helpful for determining roughly where I'm at. But you know what? We can do the algebra to find it exactly. So what I can do first is, based on this behavior, create a function that I then can use to solve that problem right here. So let's start with this. Since f of x is going to be the number of miles that I can drive in this Model 3, x being the number of days that elapses, let's write the function. So I'm going to write f of x, which is the number of miles for my Tesla, is going to be equal to, again, assuming change by constant amount, I will start at my 250 since that was my starting amount in this car, my mileage there. And I know that this car is draining. So if it's draining miles, I need to subtract off some change by a constant amount times the number of days that I need to deal with that change, right? Deal with that constant amount decrease. So it turns out here, we figure based on our graph, for every 1 day that elapses, I lose 4.5 miles. Therefore, I'm going to subtract 4.5 times some number of days, whatever number of days you want. Now I have used that information to build my equation here, that I can then go back and say, you know what? The question that we wanted to answer is, when is the number of miles exactly 0? I can go back to this equation and say, well, number of miles is f of x. I can then let f of x equal 0, set up an equation. Essentially, here's my linear equation. By the way, I knew it was linear because this was draining by a constant amount every day that elapses. So when I continue solving this, how about and because this 4.5x is being subtracted, let's move it over to the other side by adding it. So I have 4.5x equals 250. Divide by the 4.5 to continue solving for x. And I will divide by both sides by that 4.5. And what is remaining when the 4.5s divide out on the left is that x is equal to 250 divided by 4.5, which is approximately 55.5. So what I can do is I can take 250 divided by 4.5 and get approximately 55.5 days for where my number of miles is going to be exactly 0. Or essentially, it'll take this many days for my car to have no miles on the battery. Okay, so to recap, this particular video was talking about the change by a constant amount. And it's really important to keep in mind that I am talking about some amount of days that are elapsing and the constant amount that is decreasing in this particular scenario, decreasing by that same amount for every day that goes by. Okay? That's important to distinguish because there's other behavior in mathematics that doesn't behave that way. But when you have data that does behave that way, it means it's a linear, in this case, decrease, or overall just linear growth and change. So I hope that that is interesting for you. It turns out that Tesla has collected a bunch of data, and in fact, their data doesn't quite behave this way. So in my next video, I'll talk a little bit more about how their data actually matches a slightly different change that's occurring in this phantom drain problem.